So we're going to find out how to do some programming in mathematics, or some mathematics with programming. With the mult tool, you type in mult2 and it comes up first choice on your list. So here's the environment. On the top right we have the command center, and here we have the scene with a sparrow. The sparrow has its state. Its state is its position and its direction. And what I can do is I can give commands for it to change its state. So if I say forward 100, what I mean is I'm asking the sparrow to flap its wings 100 times, so to speak, to move forward 100 units. And if I press play here, this is a line editor, so it executes the command, all the commands that are on the line of the cursor, as you see. And then I can ask my sparrow to turn, change its heading, turn 35 degrees, for instance. Press play. Here it is. And then I can ask it to go forward some other distance, like 40. Press play. And then I can see a geometrical figure which is being formed, because if I turn right here, complementary to 35, so it's 180 minus 35, it's 145 degrees. I can see it pointing downwards, so it's going to create a parallel line to the first segment, and if it's 100, so it's equal, I can start seeing that I'm creating now a parallelogram. If I turn right 35, and if I want to take the sparrow back, go forward another 40, and turn it to face where it was facing when it first begun, so I turn right another 145, and my parallelogram is complete. But it's not mathematically interesting, because it's an instance of a parallelogram. If I want to create a geometrical object, which means to embed its properties, then I can create a procedure, and I can just give it a name. I could give it my name, Chronis, or I'm calling it par now. A, B, C. It has three variables. First variable is how much it goes forward at the beginning. Second variable, C, is how much it turns right. And then I can have another variable for the independent consecutive segment. Now, right is complementary, so it's 180 minus C, a little linear relationship here between the two turns of consecutive segments. Then I go forward A, I turn right C, forward B, and turn right 180 minus C, end. So if I want to run this procedure, I need to execute it. I need to select it first and then execute it, and it says par defined. So now par is has an equivalent status to any logo command. I can just ask it to execute it with three values, say 30, 40, and 50, and then when I execute, I see what it does. And now with this tool, with mult, what I can do is I can animate the procedures I've executed. So if I click on the trace, anywhere on the trace, I can see my variation tool activated here on the right. And what this does, clicking means that the program now understands which procedure this trace was built by. So if I change dynamically the value of variable A, I see what happens to my figure. I can see that it continues to be a parallelogram, nothing's changed. And if I change the turn, again it continues to be a parallelogram. And these sliders I can change the range 180, and I can put minus 180 here and see what happens once I get a full turn. Yeah, because minus right turns give me left turns. And I can look at this from an angle. So I'm looking at the same thing, only I'm looking at it from an angle. And if I click here, I go back to 2D. Now, what I've created is interesting, and it can be done with programming because it has the animation behind it. But what can be really done with programming that I cannot imagine doing it without such a tool? Well, I do have a programming language, and I do have the capability of defining as many procedures as I like. So I can make another shape, and in this shape I can say, give me, repeat, many parallelograms. How many? N. I'm not going to even say how many now. And I can put in that I want a parallelogram of ABC, and then I can ask it to turn right E degrees, and then roll right F degrees. And I will just show you what this does. So this program has not just 3 variables, it has N, and it has E, and it has F. I can put as many variables as I like. Now let's see what this does. If I click on play and click on clear screen, I can then execute parse with 30, 40, 50, and then how many times? Let's say ask it to do 10 repetitions, and then ask it to turn 30 degrees between parallelograms, and then don't turn for the moment on a different plane. So look at this, it's many parallelograms with a 30-degree angle between them. And if I change my turns here, you can imagine if I move the segments, I can see all the parallelograms changing at the same time, because procedure parses and repeats many parallelograms. If I move C, I can see the angle of each parallelogram changing, and if I move N, I get more of these. If I move E, I can see the angles between the parallelograms changing. And if I move F now, I can see them changing on a different plane. And if I look at it from the side, it's like a flower which is closing and then opening up. Okay, so this kind of thing, just by using the definition of a very basic geometric shape that you can see in first year or second or third year of secondary, I can very easily create something which is complex and it's unpredictable and it's interesting for further mathematical investigations. But the main thing is that I would never dream of giving these things to my students, because then it's like I'm giving them the math. What I would give them is I would give them a program, a different program with some variables, and I would ask them to tell me if this program creates a parallelogram or not. Now what have I done here? I've created a procedure which has a bug. It's not a procedure that has the right properties for a parallelogram, and indeed if I execute B, I can see that it does something which is not a parallelogram. I need to change quite a lot of things if I want to make it create a parallelogram. So what I would be asking my students is to try and find the bug, try and realize this means that the two turns, C and D, should actually be connected, and here they are disconnected, and this is why it doesn't draw a parallelogram. So I would begin by an investigation to get the kids to carry out experiments, see how this buggy procedure behaves, try and look into the code, try and find where the bug is, try and articulate the bug and identify the property that's missing, correct it, and then after they've created the right kind of procedure for a parallelogram, then they can move on to generating nice, interesting, complicated things which can be unpredictable and fun to do investigations with. Okay.